perfect. That Shark Top Mountain?
Sharp
Yeah.
Top, yeah, and at Peaks of Otter.
Okay, perfect. That sounds good.
Is the video working, Jack, or is it just being freezing? You're muted. You're muted.
Yeah, it was just working until you switched or something. But I saw his whole presentation and saw him.
All right, well then I'll just leave it on then. This is you, Fred. Can you see Fred's presentation?
Yes.
Cool. I'm glad you can too. All right. And then
We have Dr. Fred Hebard coming up next to talk about our efforts with our in Northern Virginia, we have 3 large chestnut seed orchards, and Fred will explain why they're there and how they're coming along.
and you just click these arrows, Fred. Or do you want me to do it for you?
Uh-oh. That's big. Well, what I'm talking about is traditional back crossing, which is what we used to do exclusively in the foundation. I'm not gonna go over this diagram, but you'll have been hanging out at chestnut meetings. You've seen it in the past. And basically just illustrate repeated crossing to American chestnut, back crossing to American chestnut to make the trees look like an American chestnut. And then with selection for blight resistance to each stage. So, and it's a geometric progression. You go from 1/2 American with the first cross, and then you cross back to an American chestnut for the second cross. And that cuts the fraction of Chinese genes down to 1/4, and it goes to 1/8, 1/16 for the third back cross. So it's a pretty powerful way to get rid of donors genes, except for the trait you want, which is blight resistance in our case, and to recover trees that look like American. And we have done that. And you know, this is Kathy Mays, who was a dear friend. It doesn't show up on the screen.
No, it goes right into TVs.
Well, that's nice. Interesting. Well, anyway, that's Kathy Mays. She's gone now, but she ramrodded the Virginia chapter for a long time. And she was very much interested in the back crossing program and negotiated. At that time, VA-TACF wanted us to have these seed orchards on public lands. They thought they could get better control than on private lands. So she negotiated for 3 seed orchards. And this is her last hurrah. She's standing in the Blandy Experimental Farm in Boyce, Virginia, in the first year of planting at that seed orchard. I don't need this, do I? And planning's usually fun. And all of it can be painful. It's farming after all. But it's it makes you feel good to get out there and work with chestnuts. This is the result of some of the plantings. Maybe I can go around the sides like that. Here's planted in 2021, and I guess the photograph was taken in 2022, so they're a year old. Planted in 2019, so these are 2 years old, and I think 1 year old in the background. And then planted in 2018, so these were 3 and 4 years old. And we were talking about this earlier. during the meeting. The secret to getting these trees to look like this was to apply fertilizer. And, we generally put down 100 to 200 pounds of nitrogen per acre. And as well as maintenance amounts of phosphorus and potassium. And the rates can drop. And Banshee, we were required to use organic methods. So we had to use organic fertilizer and organic herbicides. And they all work. They're just about 10 times more expensive than conventional fertilizers. This is Blandy in 2021 when we only had 7 plots left to go. And so a lot of effort went into this, and Blandy is completely planted now in terms of plots that have been planted at least once, and we've got about 500 nuts left to go to finish planting all of our seed orchards, which is a total of 15,000 seedlings. And TACF has a lot of seed orchards, especially up in Maine, Pennsylvania, Meadowview, of course, Massachusetts, Rhode Island, Maine, Maryland. They're all up in the tens of thousands of trees. And well, I was sort of hired to run these seed orchards. I didn't really want to volunteer, but I don't know, Tom gave me some nuts and said, okay, we're gonna be planting these tomorrow. At Banshee Rigs, lay out the plot and get them planted. Thanks, Tom.
My pleasure.
And then I was pretty successful at Blandy too. And so they gave me the whole dang thing to ram on. So that's what I've been doing, just conducting the breeding program, getting her done. And using the old fashioned methods that I developed, and they do work, by the way. I might add that what the TACF is doing now with the recurrent genomic selection, it's another form of recurrent selection. You can have recurrent selection for phenotype, recurrent selection for genotype, and then there's other ways you can slice up the term. But at any rate, it's another way to do recurrent selection. It's a more efficient way. If recurrent selection for genotype, you generally would progeny test perhaps 100 progeny from each tree that you want to evaluate. And we might want to evaluate 3, 4, 5,000 trees. So times 100, that's 300. 500,000. Yeah, that's just for one. That's just for Meadowview, and then all these other guys have to do the same thing. So it's not very efficient, and you obviously revert to a more efficient way to do it. And genomic selection is one. We first put in a proposal to do genomic selection to the USDA in 2012 or 2013, and got funded in 2015 with a competitive grant from the USDA, which I was the PI on that one. So I'm just trying to say this, I'm not against genomic selection. So anyway, we have a lot of seeds. What should we do with them? Well, what do they look like? These are some B2F3s on the left. They were planted in 2004. The photograph was taken about 2022. And on the right are B3F3s planted in 2011. Do we have a pointer? You have a pointer, Tom? You're reaching in?
It's green. We do better on this.
No.
Nope.
Oh, there's a little bit. There's a little bit.
How about grabbing one of those pussy willows?
Yeah. Pointer there.
Oh, yeah, that's what I was saying. Good call. I can be like, Charles Burnham, who would sit there with a little pointer, because his feet would always be pointing out the sides. Out flat. He taught genetics for years at the University of Minnesota. He used to torture all the plant pathologists. If you were a plant pathologist, you automatically got a B in genetics course. And by the way, he wasn't a plant breeder, he was a geneticist. And he, Barbara McClintock asked him to be on the paper for which she won the Nobel Prize, and he declined. So he would have won it. He would have been on it too, I think. But at any rate, here are the B3 F3s that were planted in 2011, and here's the tops of the B2 F3s, one generation earlier, planted in 2004. And so the trees are still doing pretty well. Did I skip it? These are some blight cankers on B3 F3s. This is about the best we can get. This is about like the Thompson tree. This is about the worst we get with severe swelling and reinvasion of the bark by the blight fungus. That's more or less a cruddy bark symptom. Then over here are discrete swollen cankers. See all the bumps all over it. And here is a close up of a few of them. And all these are phenotypes of resistant plants. Perhaps not ones that will do well in the forest, but we'll have to see. Here are some of the B2 F3s, a little bit bigger, and they've been bearing for quite a few years. The burrs are up here somewhere. And this photograph was taken this year, and this is an enlargement of that. There's a little guy standing there to give you scale, and they're poking their heads out of the canopy, so they're still growing and competing. Now, so this was a test in Veterans Park across the street from Kroger in Abingdon, Virginia. You can all look at that. It's publicly accessible. This is also publicly accessible on Johns Creek Mountain in Craig County, Virginia. And if you can access it, you're doing a good job, because it's a pretty rough country up there. Here's a Nide State Forest and where the cabin is there. And when we started these forest progeny tests, I think they designed the first one in 2001, and we finally installed the first one in 2009. People were always pushing us to develop, to release stuff and put it out, and we'd always fight back. I wanted to release the restoration 1.0 tree to be restoration 0.9, so it was still a beta test. But and the backcross program got a lot of heat because we didn't have a complete product at B3 F2 or B3 F3, and we had plans for that recurrent selection dating back to well before the existence of any of the first F2s. So You can get tarred with a bad rep. Just by people who have their own agenda. The objectives of the forestry progeny tests were to compare the blight resistance and forest competitiveness of B3F3s to that of positive and negative controls. So did they grow as well as American chestnut, better than Chinese? Did they resist blight as well as Chinese and better than American? And during the whole time of this breeding, we finally figured out that the goal of the breeding was to enable the species to resume evolving on its own. We may not be able to get it to a perfect stage, but if it can start increasing its population on its own, producing enough nuts to have the next generation, then it will start evolving again. Right now, it's a tree in stasis. It's frozen in the understory. Oh, and I'll try to remember to get back to that frozen in the understory bit too. And dentata doesn't have enough resistance, and Melissima doesn't have enough forest competitiveness and adaptation to the United States to do well. And this was one of the most successful progeny tests we've put out in the forest. We probably put out about 20 or 30. And they can get ruined for all sorts of reasons that are pretty much beyond your control. Cicadas might come along right at the right time to really harm your trees. If the tree is too small, a cicada won't really damage it too much proportionally. If it's too big, it just sort of shrugs off the cicada. But they can come along at just the right time and really destroy the competitiveness of your trees. That happened in one test. And then a cascading effect from that was about 9 tests were destroyed. This was more or less a clear cut, a little bit unusual. And so there wasn't a lot of hardwood competition in it, which is unusual in the mountains. But it was due to the site history that the hardwood competition was, sprouts wasn't there. And it was a fairly poor site, so it was fairly open in the understory. And there wasn't a lot of seeding in of tulip, for instance, tulip trees. It was mostly red maple and black locust. Oh, and we were also successful. We were compelled to grow these plants at the Penn Nursery up in Pennsylvania, and we usually spring lift trees that we're going to put out, but sometimes in Pennsylvania they can't lift any trees until the middle of May, which would almost guarantee the failure of your of transplanting bare root seedlings if you did it in May in Virginia. And so we fall lifted them in November and and had excellent establishment, probably 85 to 90% at 5 years old. And also these guys were small. I was told they were too small to live. The Cormanic protocol for seedlings is to grow a very large seedling, just like over your head, and then the deer won't be able to knock that guy down and browse it. But then of course you've got a huge root system, and it practically takes a bulldozer to plant one of those seedlings. I'm kidding. Where these guys were small and easy to plant, and we had a lot of American chestnut regeneration. That was the one hardwood sprout that didn't get wiped out at this site, and that was probably because they were small, compared to the other trees. So that when a tree fell on them, you know, they just it didn't do major damage to it. It was too small to be majorly damaged. But the they were bushy. They were almost like a bush. This was their second, there were 2 cycles of sort of clearing in this site within a few years of each other. And so the trees were very bushy. And I just think the deer liked the bush better than browsing on a single small little shrub. We were lucky. There was no deer control whatsoever in this site. It was long and narrow and steep because we had to put them out at wide spacing. This is getting into weeds on experimental design. It was a incomplete, resolvable incomplete block design. And I'll leave it at that. Resolvable means that there are big blocks and there were little blocks. These are the big blocks here, and this big block here subdivided into all these little blocks. Here's a little block of 5 trees, and then 5 or 10 little blocks make up a big block. And this is a heat map of the height. And then I can actually read the heights, like these are all, these averaged in this plot 19 feet tall. The tallest trees are red and the shortest trees are blue. And you can see that the incomplete block design gives you a much more nuanced view of what's going on at the site than the complete block design. But that's before you factor in mortality. So here I haven't killed anything, just averaging across the little blocks. Here are the 2 trees that made up the little block. And it gives a very rough picture. And this is too few to really do any decent statistics with it. We probably should have put in about 100 trees per treatment, rather than 25 or 50. Here's some of the trees there. Oh, and this tree is also illustrated to have a full crown. He has strong branches along here, which is unusual in the clear cut. Usually they're just one stem that goes straight up with no branching at all. But he's got a lot of branches because he's got full sunlight around the sides, and that led to a lot of nut production. Here's some nice trees that are fairly disease-free on the right and on the left. And then in the middle, this is more typical of the B3F trees we put out there with cankers, swollen areas down the stem, but still surviving. This guy here is one of the bushes that's now turned into this kind of ugly pastiche. This is a Native American chestnut sprout, and these are dead here. A lot of these guys, and these were flowering along with the B3F3s, but they're about done in from blight now, whereas the B3F3s aren't. But that doesn't mean that we have a good enough resistance here in these B3F3s, because we haven't had them out there long enough to tell. Oh, and we had bears. There's a lot of pests of chestnut, and well, I can't say that how you would squash a bug if you didn't like it, except for a Japanese beetle I could squash between my thumb and forefinger with no problem at all. I hate Japanese beetles. I hate squirrels. They eat chestnuts. I used to swerve towards a squirrel when I was driving. But bears, they're the most destructive, and I just like them.
You don't swerve toward them.
Yeah, that's probably what it is.
I hit one for you, Fred.
Oh, thanks.
With my BMW. It was not a good day.
No, not a good day at all. On the left, there's some bear claw marks where they pulled the bark down, and they took their idea of harvesting trees is just grab the branches and pull them down, and maybe throw them down to their buddy on the ground. And they'll completely destroy the tree. Or more likely, they'll just bust it up a little bit. And this is a very large tree. This is one of the larger ones on the plot. 32 feet tall, 7.5 inches diameter at 11 years of age. And these are other chestnut sprouts, but there's plenty of other regeneration in here, and they're hanging in there or number one, tree on the plot right now. So they're behaving like an American chestnut. Now, whether or not they're going to grow to 100 feet tall, well, we'll know when they do that. We wanted to know how many of these trees were flowering. Obviously, if a bear had been attacking them, well, they've been flowering and fruiting. But the bears don't attack every tree, and during the summer, you can't see up here very easily to tell whether the things are bearing or not. So we flew a drone, and it's right underneath that arrow, John, the target.
Oh. Yeah,
Oh, well,
underneath, you hit the little bar.
yeah. Well, there's a little 1 foot square here. It was half black and half white. For whiteness, because of the low res of the photograph. And this was taken from a drone probably 100 feet up in the air above it. There it is. But it looks all white, but it really was black and white. And you can't really tell, you can't really make out the leaves at all. But you can tell the difference between the plants. So hopefully we'll be able to say this tree is American chestnut, or this tree is a chestnut, and this tree is not, and then detect birds on them. We think that'll be possible, but there still is a lot of processing time.
Yes.
Yeah, the reason this photograph is such low resolution is just to be able to process the data in a timely manner. I don't know what it.
Yeah, we may learn we have to fly it lower next time.
Yeah.
We kind of guessed at what we thought we did.
Oh, and I should add that there have been articles in the paper, various papers about the blowdowns from Helene in North Carolina. We also had blowdowns from Helene in Virginia. So probably a very large acreage has been blown down of the canopy in the southern Appalachians, probably order of 100,000 to 1 million acres. And this will probably be when this occurs, where chestnut is growing in the understory, it grows up and gets big. It's much bigger than the trees that are shaded right now. Hanging on in the understory, the little tree that's half inch in diameter in the understory can be up to 40 years old. When I measured them, about 39 years, and probably 80 years now. I measured them 4 years. They're just very slow growing. They get exposed to full sunlight and boom, up they come. And they're slow growing. Well, they're small because they're slow growing. And small trees can't bear enough spores with blight fungus, cause an epidemic. So it just let the disease is just puttering along in the understory. But if you release the trees, they get big, then you get more than one daughter canker per mama canker, and you get an explosive epidemic. And then about 10 years after cutting, all your chestnuts die. We saw some dying chestnuts. And things revert back to normal, or all the chestnuts are wiped out completely. If the wipeout occurs under more richer sites with more competition, and with xeric sites with less competition, the sprouts can persist, the sprout clusters can persist. Well, with this blowdown, we didn't get a clear cut, we got a selective cut, as it were. And the chestnut will not grow as fast in the selective cut as it does in the clear cut. And not as many individuals will get big, so you have a lower density per acre and a smaller stem size for a longer period of time. So that'll slow down the epidemic. It's taking about 10 years like it does in a clear cut. It might take 20 years. But there is going to be a huge epidemic of blight 20 or 30 years from now. And most of these sprouts in the forest today have not been very vigorously selected for blight resistance. When blight came through, oh, sure, it killed 99% of the trees or whatever. But it didn't kill all of them. I've talked to sawyers who were cutting living chestnut in the 50s when it came through Meadowview in the 30s. And then there was a tremendous salvage after they were very well organized by the USDA. A fellow named Flippograph. They really managed to salvage most of the chestnut in the forest, where you drive around and all you see were stumps. You very rarely see snags because they were all salvaged. Now the stumps are mostly gone, so the evidence is gone too. But nevertheless, there was tremendous salvage, and so that drove the tree smaller and into an endemic situation before there could be selection for blight resistance in the native population. Now, I'm not claiming that, like I said, that it's a very high frequency resistance, but we would expect to see some somewhere. If any other test is our guide. The chestnut is probably about 1 in 200 million has survived. I think it's 200 million. I mean, I'm going on recollection. I won't be able to calculate it now. That's 1 out of 200 million chestnuts survive the blight. These are the LSAs that you're talking about. Versus in elm, about 1 in a million that have resistance. So chestnut blight is unprecedented or unmatched in the degree of destruction it causes to a single species. It was well diversified, had full genetic diversity, and a well-established population in a very good niche. So it's very unusual that it's being wiped out by blight. At any rate, the first selection on a large scale that we're going to see in the Southern Appalachian, which is the heart of the range, that will be in the next 20 years. And I think it would be a good idea to have a well-organized program to get out there and see what we've got.
Jared, I will do it.
There you go. So, yeah, we just have to get going on it, but there's no rush. If we don't get it done tomorrow, it'll be okay. But on the other hand, you don't want to procrastinate for very long. Oh, so blight resistance. So this is the ranking of the families that were put in this test. And the third column is blight severity. And this was the one American control we had in there. And it had a score of 18. And it's not followed by an A, so it's significantly different from all the twos that have an A after their name. All the ones with an A after the name are not statistically different. And all the ones with a B after the name are not statistically different. But some of these guys are have less severity than the American. So there is some resistance. We were able to backcross resistance into American chestnut, which indicates, by the way, that it's not fully highly polygenic system, or at least in terms of following for Sir Ronald A. Fisher's infinitesimal model of impairments of quantitative traits. He was the one who invented the F-test, if you've ever heard of that. That's probably the primary test of significance in statistical endeavor. Most of statistics, by the way, was invented by biological mathematicians. Tukey for the t-test. I can't remember the guy who did the chi-square test. He was a biological statistician. The F-test for Fisher, so forth and so on. Of course, they were all much smarter than I am. I think Fisher's headmaster at school was asked who was the most sharpest mathematician who ever came through, and it was Fisher. This is in Britain, and he got a job at the Rockhampton Experimental Station, which is the premier agricultural experiment station in Britain. And they said, analyze our data. And they had about 100 years of data. So he was kept busy for a while. But he helped develop the quantitative genetics that underlies our recurrent selection program. And also was one of the first, along with several other famous guys, to reconcile quantitative genetics with Mendelian genetics, which was a big deal back then, at least in theory, when you could start to have genetics make biology more intelligible. Best families had good parents. This is the blight score of the parents of the D5 1789, up top 32. He's a blight 2 class, and another top ranking parent is W2 32108. He's got a score of 38. And so some of these guys may have been pretty good mamas, but they had lousy daddies. We don't know who the daddies are in this set of data. Some of them are excessively Chinese looking. This guy is only 60% American and 40% Chinese, whereas a lot of the rest of the families are fairly high fraction Chinese. That's the average across the whole family. And we have one guy in there who has Phytophthora resistance, and so he can pass along. This is these are the same data now, where you can see the individual members of each family, and I guess anything above an 80 here is probably pretty good resistance. These scores are this is not the LUP score. This is just the average of the phenotypic data that we took, which was based upon the standard scoring method, which I developed, by the way. But all these metrics of blight resistance, the best test is to get a tree after a while, and all the other tests you've got to be able to test faster than waiting for a tree to develop if you're going to try to breed. So you need these quick tests, but that's your final test. And here's a little American who was planted at the same time with this Chinese. That's the same house, but they were right next to each other. So the Chinese have better resistance. It's able to grow bigger because he's got resistance. So conclusion that we have some good resistance here is tentative. We'll know better in another 10 years from now. And it would help if we could get a quantitative geneticist to look at our data. I don't pretend to be a quantitative geneticist. I hope you can tell that. Although I can understand what they say, I just can't reproduce it. And if they're lying to me, I can't tell if they're lying. And we measured another test in that area this winter, or last winter. I finally got all the data back. I destroyed the database record for this planning back in March. And finally rebuilt it yesterday, which led to me spending half the night getting this talk together. There's good nut production at the site, but that's not unusual. We did all of our breeding early on in Meadowview in these clear cuts. And if you want to find trees that are fruiting, find trees that are growing in the open somehow, such as along the road or out in the middle of a field, or where the full crown is exposed to sun, you can get enough carbohydrates for the tree to decide that he's going to fruit, or she's going to fruit. Yes, or he's going to flower and she's going to fruit in the same tree. Sorry. And still we're gonna have to see natural regeneration, not just production of a few nuts, but production of the next generation to say that we've achieved our goal. And well, Carl Absher, who really spearheaded this work here, thought we had a little something here, and I hope so too. Oh, and bears. They're not nice to chestnuts. And I wonder whether bears help keep the chestnut short. It's not as tall a tree as an oak. Well, oaks were 135 feet. Tulip trees were 160, 150 feet. White pine got to 250, 300 feet. This is virgin timber. And chestnut was relatively short at 100 feet. It had great girth. You see the pictures of the whole family fitting in the hollow tree, but it wasn't a very tall tree. And that 100 feet is probably the average height too. So did bears keep them short? I don't know. And then perhaps they were short because they managed to beat the competition. They got up there and they umbrellaed out to suppress everything else. And that's it.
Questions?
For this all stunned silence. Oh, ask me, Tom. Go on.
How did the trees do in Sky Meadows?
They're doing very nicely.
How taller than you?
Oh, yeah.
Pretty
We've inoculated all the trees planted. About 5 or 10 plots down the long stretch, and we'll probably finish inoculating that this year or possibly next year. Except for a few.
Let me check. So, we have two options on, well, we have two things. We spoke about three things, really. First and third together. Oh, okay. I'll let you know. So, there's or you might tell us a little bit about the planting.
Concrete?
Yeah, concrete.
Well, actually, the Bedford area master gardeners of whom several are here today, if you want to raise your hands, organized a project to plant